Let's talk about some of the terms that you have in this section. It's familiar to the HL student. Again, the SL student may don't know that one. And those concepts of the pKa, pKb, and pOH. Okay, so we want to introduce these terms here. You know that the p is a function and it means negative logarithm, okay, of something. For example, the pH means negative logarithm concentration of the H plus. So we have exactly the same term here. So when we say pKa, we means negative logarithm of the Ka, or acid dissociation constant. Just for review, you had it in chapter 8. Okay. When you have a weak acid like acetic acid, CH3COOH, it dissociates partially, so it makes an equilibrium inside the solution. It converts to CH3COO minus and H plus. But because this is the equilibrium, you can write the equilibrium constant for that, which for acid we call it acidic dissociation constant. It's the product of the concentration of the product, CH3COO minus times H plus, over the concentration of the reactants, which we have acid here, CH3COOH. And for the weak acid, the Ka are, for example, around 4 times 10 to the power of, it can be -5, -6, -7, -8. When it's smaller, it becomes weaker acid. Okay, so the pKa is actually the negative logarithm of this value that you have here. Suppose you have an acid which is acidic dissociation constant is 1 times 10 to the power of -4. So in that case, the pKa is negative logarithm of 1 times 10 to the power of -4, which becomes 4. Okay, you have the same concept for the base. So a weak base that we have is ammonia, NH3. When you put it in the water, H2O, because it's base, it accepts the proton from the water, it becomes NH4 plus aqueous, and water lose 1 H plus, it becomes OH minus aqueous. Again, for this one, we can write the equilibrium constant. Because we have the base, we say base equilibrium constant. So it becomes the concentration of NH4 plus times OH minus over the concentration of NH3. You know that the concentration of the liquid doesn't appear in the equilibrium constant. So same thing, suppose you have a base which the K base for that is 1 times 10 to the power of -5. So in that case, pKb would be negative logarithm 1 times 10 to the power of -5, or it becomes 5. So these are two concepts that I wanted to tell you. Okay, I have one more concept. We have pOH. What is pOH? Same as the pH, that it was negative logarithm concentration of the H plus. pOH is negative logarithm concentration of the OH minus. Okay, so it's exactly the same as the pH, but here we are finding the negative logarithm of the OH minus. Most of the time in the question they ask us what is the pH of the solution, not what is the pOH, but there is relationship between the pH and pOH. So if you find the pOH, you can easily find the pH of the solution. At 25 degrees, this relationship is available between the pH and pOH. pH plus pOH is equal to 14. So, for example, if you have solution which is pOH is 5, then what would be the pH of that solution? So you can easily use this one, the pH plus pOH, which is 5, equal 14. So from here, you know that the pH of the solution must be 9. In section 21 of the IB data booklet, the pKa and pKb for the acids and bases are given. So if the pKa and pKb in the question is not given, so you can refer to the IB data booklet to find the pKa and pKb. So the definition of pKa and pKb also is given at the top of the page. It says pKa is negative logarithm of Ka. Same thing, you have pKb is negative logarithm of the Kb, so you know what P means. In the first table, the pKa for the organic acid is given for the carboxylic acid, methanoic acid, ethanoic acid, and so on. Their formula is also given in the second column. In the next table, the pKa for halogenated carboxylic acid is given. It means you have the carboxylic acid which one of more hydrogen is replaced by the halogen. In the third table, you have pKa for the phenols. You know the phenols, you have the benzene ring, one of the hydrogen is replaced by the other groups. For example, the simplest form of that is the benzene ring, which is one of its hydrogen is replaced by the OH. They can act as an acid in some of the organic chemistry, organic reactions. So the pKa for them are given here. The next table is pKa of the alcohols. Under some circumstances, the alcohols can be the proton donor, so they can be acid. In the last table, you have the amines. You know that the amines are base. They have nitrogen, so the nitrogen has a lone pair. It can accept the H plus, so it is a base. The pKb for the different amines are given here in the last column. So you can use them if the pKa or pKbs are not given in the question.